You know what's wild? There are places in the universe where everything, time, light, space, just stops playing by the rules. That's what a black hole is, a place where gravity wins. People picture a black hole as this giant cosmic vacuum cleaner, just sucking up everything in its path. That's not wrong, but it's not the whole story either. There are different kinds of black holes, some small, some massive, some that might not even exist yet. And each type is terrifying in its own way. Let's go through them, one by one. 1. Stellar black holes. A stellar black hole starts with a star, not a small one like our sun. We're talking at least 10 times bigger. When a star runs out of fuel, it can't fight against its own gravity anymore. It collapses, explodes in a supernova, and what's left behind gets crushed into something so dense, it rips a hole in space. That's a stellar black hole. It's small by black hole standards, but unbelievably heavy. Cram a few suns into something the size of a city. That's the level of insane gravity we're talking about. They don't go around hunting things. They just sit there, quiet, invisible, pulling in gas and dust, or swallowing any unlucky stars that wander too close. You can't see them directly, only the chaos they cause nearby. Hot, glowing disks of matter spinning faster than anything else in the universe. They're like cosmic traps hidden in plain sight. 2. Intermediate black holes. Now we move up a level. Not too small, not too massive, just in between. These are called intermediate black holes. Think of them as the missing link between stellar and supermassive black holes. Scientists believe they form when smaller black holes merge or when giant stars collapse in dense clusters. But we've barely found any. They don't give off much light or radiation, so spotting one is like trying to find a dark marble floating in a pitch-black room. A few candidates have been found, maybe in star clusters or dwarf galaxies, but nothing confirmed. These could be the building blocks of supermassive black holes. If that's true, then somewhere out there, new cosmic giants are quietly growing right now. 3. Supermassive black holes. Every galaxy, including ours, has one of these monsters at the center. They're called supermassive black holes, and the name is pretty literal. They're millions, sometimes billions of times heavier than the Sun. Our galaxy's black hole is called Sagittarius A star, and it's about 4 million solar masses. These things are the heart of galaxies. Their gravity shapes how stars move and how galaxies spin. When they feed, by pulling in gas and dust, they can light up brighter than the rest of the galaxy combined. That's what we see as a quasar. Supermassive black holes are basically the universe's power plants. They can control, destroy, or even create entire galaxies. Without them, galaxies like the Milky Way might not even hold together. So yeah, they're terrifying, but we kind of owe them everything. 4. Primordial black holes. Now let's go way back, to the very start of the universe. Right after the Big Bang, space was a hot, chaotic mess. Matter and energy were crammed together so tightly that some spots might have collapsed under their own gravity, forming tiny black holes. These are called primordial black holes. They could be super small, smaller than an atom, or as big as a mountain. If they exist, they've been drifting through space for over 13 billion years. Some scientists think they could make up dark matter, the invisible stuff that holds galaxies together but that we can't see. Others think they might have all evaporated by now. If they're still around, they're practically invisible. Billions of tiny black holes just floating through the universe, passing through stars, planets, maybe even through you. Don't panic though, they're probably harmless. Probably. 5. Quantum black holes. This one's more science fiction than reality, at least for now. A quantum black hole could form if you cram enough energy into a tiny space, smaller than an atom. That's something we only see in theory, because it would get more energy than anything we can produce. When scientists first fired up the Large Hadron Collider, that giant particle smasher in Europe, people actually worried it might create one. It didn't. Even if it did, it would have evaporated instantly. So no one's getting swallowed by a lab experiment. But the idea that black holes might exist at a quantum level, smaller than anything you can imagine, still blows people's minds. 6. Binary black holes. Now picture two black holes orbiting each other. That's what we call a binary black hole. They circle closer and closer over time, spinning faster, twisting the fabric of space around them until they finally collide. That collision sends ripples through space-time itself, gravitational waves. We actually detected those for the first time in 2015. Two invisible things in deep space crashed together, and the aftershock literally made space ripple. We measured that ripple right here on Earth. Think about that. Two invisible things in deep space slammed together, and we felt it. That's how powerful they are. So why are black holes so terrifying? Because they mess with everything we understand about reality. They bend light, twist time, and warp space. They break the laws of physics we thought were solid. You can't even see them, only what they do to everything around them. But here's the thing. Without black holes, galaxies wouldn't form. Without galaxies, there'd be no stars. And without stars, there'd be no planets. No us. So black holes aren't just destroyers. They're also creators. They keep the universe running, quietly, invisibly, and sometimes violently. If you fell into one, time would slow down until it basically stops. From your view, you'd never reach the center. From ours, you'd just vanish. That's the crazy part. They don't just end things, they rewrite the rules of what ending even means. That's why black holes are so fascinating. They're the universe's biggest mystery and its biggest reminder that we still don't know how everything really works. Somewhere out there, billions of them are waiting, silent, patient, and always hungry.